Here we're going to find a complete solution of the given linear system, or show that it is inconsistent. That means show that it has no solutions. So in this case, we're going to use the first equation to operate on the other two. So I'll copy down the first equation, the opposite of x plus 2y plus 5z equals 6. Then I'm going to take equation 1, add it to equation 2 to create the new equation 2. I'm then going to take 4 times equation 1, add it to equation 3 to make the new equation 3. So in this case, the opposite of x plus x, the x will disappear in the second equation. 2y plus 0y is 2y. 5z plus negative 2z is 3z. And 6 plus 0 is 6. Now, 4 times equation 1 would make negative 4x plus 4x. The x in the third equation is going to disappear. 8y plus negative 2y will make 6y. 20z minus 11z will make 9z. And 24 plus 6 will make 30. Now I'm going to keep the first two equations. The opposite of x plus 2y plus 5z equals 6. 2y plus 3z equals 6. Then I'm going to multiply the second equation by negative 3, add it to the third equation, and make that our new third equation. So that would be negative 6y plus 6y. There will no longer be a y term in the third equation. Negative 9z plus 9z. There will not be a z term either, so the left side will be 0. And negative 18 plus 30 is going to give us 12 on the right-hand side. 0 equals 12 is always false. It's called a contradiction. There is no solution, and therefore the system has no solution. So, no solution, the system is in fact inconsistent. So let's go to the next example. Here we have the same instructions. We're also told if the system has infinitely many solutions that we should use a general solution where z has been replaced by the parameter t. And so we'll proceed by using the second equation to remove the x's in the other two, to make that just a little bit, feel a little bit more natural. I'm going to interchange equations 1 and 2. So the opposite of x plus y plus z equals 5. So I interchange equations 1 and equation 2. And so my second equation is now 2x plus y minus z equals negative 10. And my last equation, negative 2x plus 4z equals 26. So now I'll use equation 1 as the operator to get rid of the x's in the other two. So 2 times equation 1 plus equation 2 into equation 2 and negative 2 times equation 1 plus equation 3 into equation 3. So in the second equation, the x's are going to be neutralized. We'll have 2y plus y, which is going to be 3y. And we'll have 2z minus z, which will be 1z. And we'll have 10 plus negative 10, which is 0. For the third equation, we'll have 2x plus negative 2x. The x term will be eliminated in the third equation. We'll have negative 2y we'll have negative 2z plus 4z is 2z. And we'll have negative 10 plus 26 is 16. Now, our next step is to eliminate, and I do see I miscopied y as z in this equation, so I'm just going to fix that before we proceed. So I have a couple of choices here, as we always do. There's more than one way to do these problems. What I'm going to do is I'm going to take half of equation 3, since I see that all of its coefficients are even, and interchange that with equation 2. So I'm going to take 1/2 equation 3 and interchange that with equation 2. So my first equation will be minus x plus y plus z equals 5. The second equation will now be 1/2 of what was the third equation. The opposite of y plus z equals 8. And what was the second equation will become the third equation. So 3y plus z equals 0. Now I'm going to eliminate the y from equation 3. I recopy equation 1 and 2. And I take 3 times equation 2, add it to equation 3 to make that our new equation 3. So that neutralizes the y term in the third equation. It will be removed. 3z plus z is 4z equals 3 times 8, which is 24, plus 0 is 24. And so now we get the opposite of x plus y plus z equals 5. The opposite of y plus z equals 8. And z equals 6. Substituting that in to equation 2 gives us the opposite of y plus 6 equals 8, or y equals negative 2. And substituting negative 2 for y and 6 for z, in the first equation gives us x equals negative 1. So the solution that I'm coming up with is negative 1, negative 2, and 6. Let's try that in the first equation. 2 times negative 1 would be negative 1, plus negative 2. 2 times negative 1 would be negative 2, plus negative 2 would be negative 4, minus 6 would be negative 10. In the second equation, 1 minus 2 would be minus 1, plus 6 would be 5. In the third equation, 2 plus 24 would be 26. And so, in fact, it does look as if we've got the right solution for the system.